October 1999, Tangshan, China. A factory floor that had been running for decades, turning out steam locomotives like clockwork, goes quiet. The last one rolls off the line. SY-1772, a 282 Mikado built the same way they had been building them since 1960. And then the machines stop, the furnaces cool, the workers go home. And that was it. The last steam locomotive ever built for commercial use anywhere in the world. Not in America, not in Britain, not in Germany. China. And since that day in October 1999, nobody has built another one for regular service. 25 years. A quarter of a century. And the skills, the factories, the entire industrial ecosystem that made these machines possible has been crumbling away ever since. Now, here is where this gets interesting. Because you would think that in 2025, with all the technology we have, with CNC machines and computer-aided design and material science that would make a 1940s engineer weep with joy, you would think building a steam locomotive would be easier than ever. You would think some billionaire with a passion for trains could just write a check and have one built in a couple of years, and you would be completely wrong. Because what we have discovered, painfully, expensively over the last 2 decades, is that you cannot just throw money at this problem. The infrastructure is gone. The knowledge is gone. The men who knew how to do this work are either retired or in the ground. And what remains is a handful of specialists scattered across the world, trying to keep machines alive that were built when their grandfathers were young. Let me tell you about a locomotive called Tornado. In 1990, a group of British enthusiasts got together with an idea that most people thought was completely insane. They wanted to build a brand new peppercorn A1 Pacific, a class of locomotive that had been entirely scrapped in the 1960s. Every single one of the original 49 locomotives had been cut up for scrap. Nothing survived. So these enthusiasts said, fine, we will build number 50 ourselves. We will call it 60163 Tornado, the next number in the sequence, and we will do it from scratch. Now in 1948, when the original A1s were being built at Darlington, each locomotive cost about £16,000. Adjust that for inflation to 2008, when Tornado was finally completed, and you would expect to pay maybe £420,000. That is what the math says. That is what inflation calculators will tell you. But Tornado did not cost £420,000. Tornado cost over £3 million. 7 times more than inflation would predict. 7 times. And it took 19 years to build. Why? Because when these enthusiasts started looking for someone to build the boiler, well, they discovered something that should terrify anyone who cares about preserving this technology. There was not a single facility in all of Great Britain that could build a steam locomotive boiler from scratch. Not one. The country that invented the steam railway, the country where Richard Trevithick and George Stephenson built the first locomotives, the country that exported this technology to every corner of the globe, could not build a boiler. They had to send the work to Germany. But to a place called DB Meiningen in what used to be East Germany, where they had kept steam running on narrow-gauge railways right through to 1988 and had never let the skills completely disappear. And this is the thing that people do not understand when they ask why we cannot just build new steam locomotives. It is not about the technology being too complicated. A steam locomotive is actually a fairly simple machine compared to a modern diesel or electric. You have a boiler. You have cylinders. You have valve gear, you have wheels. The principles have not changed since the 1850s. What has disappeared is the entire industrial base that made construction possible. The foundries that could pour massive cylinder castings. The rolling mills that could produce boilerplate thick enough to handle 300 pounds of pressure. The specialists who knew how to flange a firebox wrapper or set up valve gear by ear. All of that is gone. At Spencer Shops in North Carolina, which was once the largest steam locomotive repair facility in the southeastern United States, they used to run 3 shifts around the clock with 3,000 workers. They had a machine shop where they could cast, forge, and mill any part on specification. No outsourcing, everything in-house. A boilermaker named Clifford Spears worked there from 1942 to 1960, welding joints and seams to keep those boilers steam tight. And then the diesels came. And by 1953, every steam locomotive was off the rails. The skills of the boilermakers and pipe fitters became obsolete overnight. Clifford Spears had to find other work, and the knowledge he carried in his hands, the knowledge of how much heat to apply and when to stop and what a good weld looks like and sounds like, that knowledge started to disappear. This is what engineers call tribal knowledge, the kind of information that cannot be written down in a manual. The kind of experience that only comes from doing the same job for 20 or 30 years, learning from someone who did it for 20 or 30 years before you. And when you break that chain, when you skip a generation, that knowledge is gone forever. You can read every book ever written about steam locomotive construction and still not know how to do it properly because the books do not capture the subtle things, the way the metal changes color at just the right temperature, the sound a rivet makes when it is properly set, the feel of a bearing that is running true versus one that is about to fail. A few years ago, I read about a project in Maine where volunteers are trying to restore a steam locomotive called number 470. And one of their stated goals, right there on their website, is to preserve and revive the skills necessary to maintain a steam locomotive. They specifically mention riveting, boiler making, pipe fitting, and more that are, in their words, otherwise relegated to history books. Think about that for a moment. These are skills that used to be common, that thousands of men performed every day across hundreds of shops and roundhouses, and now a non-profit organization is trying to teach them to volunteers before they disappear completely. In Canada, there is a locomotive called Number 3, the oldest operating steam locomotive in the country, built in Glasgow in 1882. A couple of years ago, it needed new boiler tubes, and the estimates came back at somewhere between $150,000 and $250,000. And here is the kicker. Most of that money was not for the tubes themselves or even the labor to install them. Most of that money was to pay for specialized high-pressure welders because, and I am quoting someone involved in the project here, it is so specialized, the skill level is rare. A lot of people want to be high-pressure welders, but they just do not have the ability to do it to the high standards that are required. So when people ask why steam locomotives cannot be replicated, the answer is not that we have forgotten how they work. The answer is that we have lost the ability to make them. There is a difference. We have the drawings. We have the specifications. In Pennsylvania, a group called the T1 Trust is building a brand new PRR T1 duplex locomotive number 5550. And their chief mechanical officer spent the equivalent of 41 8-hour days in the state archives, scanning 1,754 original T1 blueprints. They have 99% of the drawings they need. The information exists. But turning those drawings into actual metal is a completely different challenge. The original T1 locomotives had one-piece cast frames with all 4 cylinders integrated into the casting. It was a single massive piece of metal, poured in a foundry that no longer exists using techniques that nobody practices anymore. Could you do it today? Technically, yes, but it would cost 3 to 5 times more than breaking the job up into smaller pieces and welding them together. So that is what the T1 Trust is doing. They are using CNC machines and modern fabrication techniques wherever they can, because the old ways are simply not available at any reasonable price. And even when you have the money, even when you have a major corporation with deep pockets and a genuine commitment to preservation, it is still enormously difficult. Union Pacific decided in the early 2000s that they wanted to restore a big boy locomotive, one of the largest steam engines ever built, for the 150th anniversary of the Transcontinental Railroad in 2019. They had millions of dollars budgeted for the project. They had their own steam shop in Cheyenne, Wyoming, one of the only facilities in the country that could even attempt such a thing. They had a locomotive, number 4014, that had been well preserved in the dry California climate for 60 years, and it still took them nearly 5 years and an estimated $4 million or more to get it running. That is Union Pacific, the only Class 1 railroad in America that still maintains an active steam program. The only major railroad that kept their heritage equipment and the skills to maintain it. Every other Class 1 has completely abandoned steam, and if you want to run a steam locomotive on their tracks, well, good luck with that. Insurance requirements alone will stop most projects cold. One volunteer at a preservation group in Portland told me that Union Pacific simply will not allow outside steam locomotives on their tracks, period, because of insurance concerns. It does not matter how well maintained your engine is or how qualified your crew. The liability is too high. But this brings us to another reality that makes steam preservation increasingly difficult. The Federal Railroad Administration requires a complete inspection and overhaul of every steam locomotive boiler every 15 years, or every 1,472 days of service, whichever comes first. And these are not cheap inspections. They are not a guy coming around with a flashlight and a clipboard. They involve taking the boiler apart, testing every stay bolt, examining every weld, replacing anything that shows wear. A basic 15-year inspection for a small locomotive can run $600,000. For a big mainline engine, you are looking at $1 million or more, and that is just maintenance. That is just keeping an existing locomotive running. Building a new one from scratch is exponentially more expensive. Tornado, that British locomotive I mentioned earlier, went in for its 10-year overhaul in 2022. What the original plan was to swap in a brand new boiler that was being built in Germany, but there were delays, so they sent the existing boiler back to Meiningen for repairs instead. When the boiler came back to Britain, inspectors found problems with the quality and installation of the small tubes. They had to replace every single one. And even after all that work, the locomotive did not return to steam until August 2024. More than 2.5 years after it went in for what was supposed to be a routine overhaul. This is the reality of keeping these machines alive in the 21st century. And here is something that should make you think about the fragility of all this. When Tornado's builders were looking for someone to cast the superheater header, one of the most complex components on the locomotive, the job defeated 2 foundries before a third one finally managed to produce a usable casting. But 2 professional foundries with modern equipment could not figure out how to make a part that British railways had been producing by the hundreds in the 1940s. That is how much capability has been lost. The situation in America is slightly different but no less challenging. At Strasburg Railroad in Pennsylvania, they have managed to build one of the only shops in the country certified by both ASME and the National Board of Boiler and Pressure Vessel Inspectors to construct and repair steam locomotive boilers. They can do hot flanging of boiler sheets. They can install stay bolts. They can rebuild fireboxes from scratch. But they are a small operation with limited capacity, and the demand for their services far exceeds what they can handle. There are locomotives sitting in museums and preservation yards all across the country waiting for boiler work, and the wait times are measured in years. At Tweetsy Railroad in North Carolina, they have been running steam locomotives since 1957, and their current director of engineering talks about how the skills necessary to maintain those engines are becoming a lost art. They have to manufacture their own replacement parts because you cannot just order them from a catalog. Everything has to be custom-made. Castings have to be sent out to foundries, and then their own machinists have to cut and finish each piece to specification. When Frank Coffey, their master mechanic, passed away in 1999, he left behind a new generation of workers that he had personally trained. But how many more generations can that knowledge survive? Each transfer loses something. Each retirement takes something irreplaceable. The volunteers who keep these locomotives running today are mostly older men, retirees who worked in manufacturing or engineering or the railroad industry itself. They bring a lifetime of experience with them. But they are not getting younger, and the younger generations are not lining up to learn these skills. Why would they? There is no career path in steam locomotive maintenance. There are no apprenticeships, no union jobs, no pension waiting at the end, just long hours of dirty, difficult work for the love of the machines. Some people look at China and wonder why they stopped building steam locomotives in 1999. After all, they had the factories, they had the workforce, they had the demand. The answer is actually pretty simple. By the late 1980s, China had developed a reliable domestic diesel locomotive design, and they had trained enough workers to build them in quantity. The steam was kept around as long as it was because traffic was increasing so rapidly that they could not build diesels fast enough. Steam locomotives were relatively low-tech and simple. They could be built in large numbers, and they ran on cheap and readily available coal. But once the diesel production caught up with demand, there was no reason to keep the steam factories open. The last mainline steam design, the QJ Class 210-2, was stopped production in 1988 after more than 4,700 had been built. The SY Class 282 for industrial use continued until 1999, when SY 1772 rolled off the line at Tangshan and the era finally ended. For years after that, steam kept running in Chinese coal mines and steel mills, using second-hand locomotives that were cheap and available. The last regular commercial steam operation in the entire world was at the Sandaoling coal mine in Xinjiang province, where JS-class locomotives kept working until January 2024, not 1924, to 2024. Less than 2 years ago. But now even that is finished. The diesels finally took over completely, and with that, a continuous chain of steam locomotive operation that stretched back to the 1820s has finally broken. So what does all of this mean for the future? Can steam locomotives ever be built again in any meaningful way? The answer is complicated. Yes, if you have enough money, enough time, and access to the right specialists, you can build a steam locomotive today. The T1 Trust is proving that with their 5550 project, which is now nearly 60% complete and on track for a possible 2030 debut. Tornado proved it in Britain. Various narrow-gauge projects around the world have succeeded in building small locomotives from scratch. It can be done, but it will never be cheap, and it will never be easy. While the industrial base that made steam locomotive construction routine has been dismantled and scattered, the workers who carried the essential knowledge in their hands and heads are disappearing. The regulatory and insurance environment makes mainline operation increasingly difficult, and the simple economic reality is that there is no commercial reason to build these machines anymore. Every new steam locomotive built today is a labor of love, funded by donations and staffed largely by volunteers, justified only by the desire to preserve something that our great-grandfathers took for granted. In Germany, the mining and works keeps building boilers and doing overhauls because they never completely stopped. In Cheyenne, Union Pacific maintains the last active steam program of any major American railroad because they made a corporate decision to keep that capability alive. At Strasbourg and a handful of other small shops, a skilled craftsmen continue to practice arts that most of the world has forgotten, and in basements and garages and preservation sheds around the globe, aging enthusiasts keep tinkering with machines that were old when they were born, trying to pass on what they know before it is too late. The factories that built these locomotives are long gone. Baldwin closed in 1972, Alco in 1969, Lima back in 1951. The roundhouses where they were maintained have been demolished or converted to other uses. The men who ran them have retired or passed on, and the knowledge of how to build a steam locomotive from raw materials to finished machine, knowledge that was once common across dozens of facilities in a dozen countries, now exists only in fragments, scattered among a few hundred people worldwide who are trying desperately to keep it from being lost entirely. Somewhere in Denison, Ohio, the frame of PRRT 15550 sits waiting for its boiler to be mounted. In museums across America, a beautifully preserved locomotive stands silent, their boiler certificates expired, waiting for overhauls that may never come because there is neither the money nor the manpower to perform them. And in Cheyenne, Big Boy 4014 keeps making excursion runs, drawing crowds wherever it goes. A reminder of an industrial age that most people alive today never actually experienced. The age of steam lasted barely a century and a half. Learned from Trevithick's first locomotive in 1804 to the last commercial builds in 1999, just under 200 years. And already, just 25 years after the last factory closed, we are struggling to keep the survivors running. The machines are still here. The knowledge of how to build them is fading fast.